Hello, welcome to Flip. So today we are on noble gases, also known as group 0. And group 0 elements are very unreactive. Okay, they exist as monoatomic atoms. Okay, in the case of argon here, okay, and they have low melting and boiling point. This is because, for example, if an argon is attached to another argon, okay, this interatomic force is very easily broken, and hence they actually prefer to live alone, okay, as a atomic atom themselves instead of being bonded to another compound or element. So why are they important? Is because they provide an inert environment. Okay, what do I mean? For argon, it's used to fill light bulbs and to manufacture steel. And for neon is to use in colorful lights, and helium is to fill balloons. Okay, so imagine all this environment, light bulbs and balloons. Okay, they are very reactive. Okay, they'll just pop, right, or explode. So that's not what we want. So we want a gas that's able to provide a stable condition for all these processes to carry on. Okay, and that's what we mean by inert environment. Okay, now we'll move on to why are group 0 elements inert. Okay, this is because of their electronic structure. Okay, you can see that they have completely filled outermost shell. What do I mean? Look at all the shells here. Okay, they are all completely filled. Okay, for helium it's 2 electrons, that's the maximum for the first subshell. For neon it's 2,8, that's the maximum for second subshell. Argon 2,8,8, that's the maximum for third subshell, which is 8 electrons. For krypton and xenon I didn't draw, but the fourth subshell maximum is 18. Fifth subshell maximum is also 18. So you can see that they do not lack any holes. Okay, they don't require electrons to be removed or added on. Okay, they have perfect outermost shell configuration. Let's compare them to, for example, a chlorine atom. Chlorine atom has electronic configuration of 2,8,7, which means 2 electrons in the innermost shell, 8 electrons in the second subshell, and 7 electrons in the third subshell. And you can see that there's a hole here. Okay, it's 1 electron away from neon, actually, from argon. Sorry. Okay, this 1 electron is missing in chlorine atom. So chlorine is very reactive is because it wants to fill this hole very quickly and very desperately. So what's the best way? You react with another chlorine atom. Okay, in this case it has pink electron. Okay, this is just for illustration's sake. Okay, so what they do is they actually share the electrons such that each atom, now you can see that they have 8 electrons. Okay, let's look at the green one. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this green chlorine has 8 electrons. This pink chlorine has also 8 electrons. Okay, so now by sharing their electrons, they have achieved completely filled outer shell. Okay, but let's come back to group 0. They do not have to do this at all because they already have a complete outermost subshell. Okay, and hence they are very stable as a monoatomic. Mono just means 1. Okay, and di means 2. Okay, so for chlorine they have to form 2 atoms. Okay, that's why it's di. Whereas for group 0, they just have to be alone. Okay, that's why they are called mono. Okay, and that is all for noble gases.